Now, the trig functions are also an example of periodic functions. And periodic functions don't have to be just trig. It's any function that sort of repeats itself over and over again. So a function is periodic if there exists a positive number p such that the function of t plus p is the same thing as the original function at just t. And this is true for all t in the domain. The smallest positive number p for which f is periodic is called the period of the function. And hopefully that makes sense why the trig functions would also be periodic. If you think about that unit circle, and we think about the angles, we can keep making angles that go around and around and around that unit circle, right? And you're still kind of coming back to the same points on the terminal side. So your outputs are really repeating over and over and over again as you keep moving along and around that circle. And what happens is most of the trig functions are periodic with period 2 pi. So sine, cosine, as well as secant and cosecant all have period 2 pi, which means that, for instance, something like sine of 5 pi over 2, what I can do is kind of pull that first 2 pi rotation out, and it's going to be the same answer as just sine of pi over 2. So you can kind of take away that 2 pi like we did with coterminal angles very similarly to get that result there. And that's the same thing for cosine, secant, and cosecant. Now, tangent and cotangent are actually a little bit different if you actually look at the values a little bit more and go into those ratios there, because tangent is sine over cosine, right? And cotangent is cosine over sine. They're actually a little bit different. Their periods are pi instead. So they repeat their values much faster. So tangent has period pi, and so does cotangent. So for instance, let's say I'm trying to find tangent of 3 pi over 2. I can pull out that pi, and then whatever the answer of tangent of pi over 2 is, it would be the same result. So again, these are just little tips that are important, but also make your life easier. You may know the answer for sine of pi over 2 or tangent of pi over 2 right away off the top of your head as you get through the course, but you may not know the answer for sine of 5 pi over 2. So if we can kind of boil it down to the more base angles that we're used to, it just makes things a little bit easier. So for instance, let's say I want to find sine of 9 pi over 4. Again, I'm going to use the idea of kind of pulling out that 2 pi because I know sine will repeat itself every 2 pi. And clearly 9 over 4 is more than 2. That's important here, right? 9 divided by 4 would be 2 and 1/4. Well, it goes in 2 times and you have 1/4 left over. So I'm going to use the idea that it's periodic, and I'm going to kind of pull that 2 pi out. So this is 2 and 1/4 if I change that 9/4 into a mixed number. So I end up with 1/4 left plus that 2 pi. So I'm just looking at sine of pi over 4 here, and we know that one. So we've looked at this one already. It's root 2 over 2 for the answer. Now let's do tangent of negative 5 pi, excuse me, over 4. This one has different ways to do it because you have a negative. So one way to do it is to remember that tangent was an odd function. So what happens is we can rewrite this and take that negative out, basically. So this is the same answer as tangent of, or negative tangent of 5 pi over 4. And then I'm noticing that 5 over 4 would be 1 and 1/4 if I change it to a mixed number. So there's definitely 1 whole pi in there. So I can use the idea of it being periodic. So this becomes, let's see, I have a pi over 4 left plus a pi. That pi isn't really going to matter because it's periodic. So negative tangent of pi over 4. And we already saw that the tangent of pi over 4 is 1. So this becomes negative 1. So here I'm using both the idea that it's periodic with period pi, and I'm also using the idea that tangent is an odd function. So that negative on the inside, I can actually quickly work with it rather than trying to think about using a negative angle instead and going into an opposite rotation. I can, using the idea that it's odd, take that negative out and then find what's happening with the positive angle and get my answer pretty quick there. So now what happens here when we're periodic, it doesn't have to be just one single rotation or 1, 2 pi or 1 pi that we kind of pull out. You can do this over and over again. We saw a very similar idea with coterminal angles. So for any integer n and real number t, sine of t plus 2 pi n is still equal to sine of t, meaning that no matter how many 2 pi's that there are that you can like take out or that you go around the circle over and over again, it doesn't matter. You can keep removing those because it's all periodic. It's all bringing you back to the same answer. And it's the same idea for cosine. It's the same idea for secant and cosecant as well. I'm not going to write those here. They're not as common, but they are still used. So cosecant and secant also have that same 2 pi. And then for tangent, it's just pi, right? So again, however many values of pi that you can kind of subtract from that angle, you're still going to get the same answer. And same thing for cotangent there. So these tend to be our main ones. Obviously, you'll still see cosecant and secant and cotangent as well. But usually sine, cosine, and tangent tend to make up the bulk of what we look at. But you do have those other ones that are periodic too. And again, it really works the same way. So if you need to take away more than, just 1, 2 pi or 1 pi, you can do that just like we did with coterminal angles. The last thing I just want to mention very briefly is that many of your calculators can work with these functions as well. So I'm bringing up my app here, and this app mimics the TI 8384 calculator. So I'll just let you know for calculator apps, this one is one of my favorite. I have iOS, so I have an iPhone. And it's often called Graph and Calc 83 or Graph and Calc 83. It's spelled different depending on how they update it. It's around $6, so it still costs a little bit of money, but it's much cheaper than a TI 83 or 84, and it works exactly the same, and it's on your phone, so I really like it. If you have Android instead, the one that students usually like is called Graphing Calculator X84. That one's slightly harder to work with. It's still very, very similar, but sometimes the graphing on that one gets a little bit weird. So I also recommend, the Desmos app for graphing as well. But here you can see I have sine, cosine, and tangent right on here. I don't have cosecant, secant, and cotangent excuse me, on this calculator, but you can use the reciprocal identities to get the answers. You do want to make sure that you're in the right mode. So if I go to mode up here, you'll see that you can choose, let's see where it is. Oh, down here, how you want your angles. Are your angles going to be in radians? Are your angles going to be in degrees? So you need to make sure that your calculator is in the correct mode or it won't give you the right answer. So let's say I put it in radians. I can go ahead and find the tangent of pi over 4 and just hit enter, and it will give me that value of 1. Or what was the one we just did? Tangent of negative 5 pi over 4. Oh, I hit something. Oh, negative is negative 1. So they can do these values for you. Sine of 9 pi over 4. So here again, they're giving us the decimal answer, but that was the square root of 2 over 2. So that's a good one to start recognizing that this is the square root of 2 over 2 if you're using your calculator, but it can do that. If I want something else, like again, if I want cotangent, I would probably use 1 divided by the tangent, and we'll just do pi over 4. So you would want to use your reciprocal rules there to accommodate using the calculator. It's not the inverses. So sine -1, cosine -1, tangent -1, that's not what you're using for, cotangent and things like that. Right? You can see you get a totally different answer. So those are not cotangent, cosecant, and secant. So you have to go with just the regular buttons, and then you'll use the reciprocal identities. The fact that tangent is the same thing as cotangent is 1 over tangent, for instance, to get the other values. So just a little tip here, make sure you watch the mode on the calculator. Make sure you're in radians and not degrees for most cases. And then go ahead and you can, again, practice some of these and check your answers as well on your calculator.